Hi, everyone. Welcome to the Neuroscience Public Lecture, Winter 2022. Thank you for joining us. My name's Ethan. I'm one of the co-chairs of the Public Lecture Series, and I'll be the MC this evening. I'm a third-year student in Penn's Neuroscience Graduate Group, or NGG, and a member of GLIA, which is a student group within NGG that's focused on neuroscience outreach, professional development, and community building.
My name is Yu John. I'm one of the other co-chairs for the Public Lecture Series. My job today will be to moderate the chat and sort questions for the question and answer portion. The Public Lecture Series started in 2014. This is our 15th event and the third one to take place fully virtually due to COVID-19. The purpose of this series is to inform the Philadelphia community about where your tax dollars are going and to share with you the amazing work that is being done by scientists at Penn and the surrounding institutions.
The series is brought to you by Penn's neuroscience graduate students who thought hard about which topic to cover today. And after lots of deliberation, we're happy we chose the hippocampus, a brain region worth remembering. And we highly encourage you to participate and ask questions throughout this event. Really excited to introduce the speakers and share with you lots of cool stuff about the hippocampus. So speaking of questions, let me just explain a little bit of the logistics. So if you never used Crowdcast before, there is an Ask a Question button towards the bottom of your screen, right next to the button that says People. So in addition to using the chat, you can, if you have a specific question that you want us to put in the Q&A, use the Ask a Question button, and people can vote on that. And we'll be doing individual Q&As for each speaker, and then at the end we'll be doing a group panel Q&A. So with no further ado, I'm going to start the introduction. You can see this, great. Okay.
Everything looks great.
Okay, thanks. So today, first we're going to start with a quick activity to get you started thinking about memory and how memory works. Then I'm going to do a quick introduction to the hippocampus, and then we'll have our first speaker, Dr. Douglas Coulter from CHOP and the University of Pennsylvania. We'll have our second speaker, Dr. Amelia Aish, also from CHOP and the University of Pennsylvania. We'll have our third speaker, Dr. Dong Wang from Drexel University School of Medicine. And finally, we'll have the combined Q&A with all speakers. So as I said, we're going to start with a quick activity having to do with memory. So your brain uses a bunch of different memory systems. It's actually not just one. There's not just one way you remember things. They have different properties. So they last for different amounts of time. Some forms of memory last only over seconds, while others last for minutes, days, or even years. And also some involve the hippocampus, while others don't. So one consequence of this fact is that you have multiple different strategies for recalling something you've recently seen. And it may be surprising which things you can remember and which things you can't. So, okay, so now I'm about to show everybody a series of words. You'll see each word for 1 second. So just focus on the words that you're going to see and try to remember as many as you can. Okay, it's going to start in 3, 2, 1, go. Okay, so now you're going to click the green button that you can see on your screen to go to our website, or just type in this URL, and then scroll down to the Google form and enter all the words you remembered. Okay, I'm going to start showing the results. They're still coming in. Oh, you can't see it? Okay. Oh, I know. There are some right now. I have some black things covering parts of this screen, just in case anyone's confused, so that I don't give away the answers. So. Okay, it looks like most of the results are in, so I'm going to reveal, first of all, the words. And it's a little bit noisy, but I think we can kind of see an effect if you notice that it seems like the first words are the most frequently remembered. And that's actually exactly what we'd expect. That's called the primacy effect. And then I'm not sure you can quite see, there's also a recency effect that happens where you're supposed to be able to remember the most recent words. That might be happening, but it's kind of a U-shaped. Yeah, anyway, so this is one experiment that's been done many times, and it's thought that there's perhaps different forms of memory that are used to remember most recent words and the earliest words. So that's cool. Kind of worked. Okay, so now I'm going to go back to my introduction. So what is a hippocampus anyway? So this is an illustration of someone's brain, right? And so the hippocampus is this sort of banana-shaped structure in the center. It's technically located in the brain's temporal lobe, which is this bottom part, and in the medial part of the temporal lobe, which means it's towards the center. Its most important and most well-known role is in memory, as we've been talking about. So it helps you recall recent events. It stores what's called episodic memories, which are sort of, it's almost like a movie of what's recently happened to you. It's also very heavily involved in spatial cognition and spatial memory. So it helps you remember where you are and know where you are. It's also very active when you are not during sleep. And so some of the roles it has during sleep are going to be the topics of these lectures as well. Also, a fun fact about the hippocampus is the name hippocampus actually comes from a Greek word, the Greek word for seahorse. And as you can see, if you extract it from the brain, it does kind of look like a seahorse. So quickly to go over the broadest structure of the hippocampus, when you zoom out like this, it's actually pretty simple. So there's two main structures, two main parts of it, the DG and the CA, or the dentate gyrus and the cornu amonis. They're both pretty interesting, both have interesting roles. The DG is extremely interesting actually because it's only there are only two brain regions where new neurons are born in the adult brain, which is called adult neurogenesis. And the dentate gyrus is one of those regions. So you can see that in this image. These red spots are new neurons that have just been born, stained for that. And so Dr. Aish is especially, she focuses on neurogenesis, and in her talk you'll learn more about the role of this in memory and psychiatric disorders. Another fact about the hippocampus, it's not It has functions, but it also has dysfunctions. So medial temporal lobe epilepsy is a common form of epilepsy. 60% of epileptic seizures are focal, and most of them start in the medial temporal lobe where the hippocampus is located. So treatments for MTL epilepsy are still being developed. One treatment is a lesion of the hippocampus, removing it, which is very drastic. And so Dr. Coulter will tell us about less invasive alternatives to that are being developed. So speaking about lesioning the hippocampus, here's a little bit more about its role in memory. So in 1953, very famous epilepsy patient, HM, or Henry Molaison, he had about 2/3 of his hippocampus surgically removed. I say his hippocampus, as actually 2 of them on either side. So he had both of his hippocampi were lesioned. And that had a severe effect on his memory. So he became unable to recall events, I say, starting from about 2 years pre-surgery. So that counts things that happened to him up to 2 years before, but also things that happened to him afterwards. So he became unable to form new memories of events as well. So that was obviously severely impacted his life. At the same time, not everything, not all his memories were gone. He could still remember things from earlier in life. He could also remember how to do things, which are called procedural memories. And he could remember things for short amounts of time, which is called working memory. So from that, we learned the specific role of the hippocampus. As I say here, it's required for processes that allow events to be recalled. And so there's several processes involved here. One of those important ones is memory consolidation. So memories are stored by the hippocampus, but they're also exported from the hippocampus to the rest of the brain, the cortex. And Dr. Wang is going to tell us much more about these processes and also the involvement of another area called the amygdala. All right, so just to review the speakers we have today, Dr. Doug Coulter will be giving a talk, Hippocampal Circuit Dysfunction in Neurologic Disease. Dr. Amelia Eich will be telling us about the stressed and spaced out hippocampus, what's memory got to do with it. And Dr. Dong Wang will be telling us about how memories are acquired and consolidated. And so with that, I'm going to turn it over to Vanessa to introduce our first speaker.